Up until now in these videos, I have told you a little bit about my own experiences and also building on some of my colleagues' experiences about how to best put agentic AI to use, some of the pitfalls that can occur and how you might overcome them. Now, it's important also to ground these types of tips in research. It's new, so there isn't a lot of research, but there are definitely pointers which will help us better understand, how much we can really expect from it. So there are researchers who've dug deeper than I have into the use of agentic AI. Already during 2025, researchers found that large language models could reliably suggest the correct test for at least textbook examples of how we should analyze particular data sets. This is a result from Shukla from 2025. They tried 6 different models: ChatGPT, Claude, DeepSeek, Gemini, Grok, and LeChat. And they looked at 20 textbook scenarios, and it suggested 100% of the time the correct one. This result was later replicated by Sibo and Wang, and they went on to ask it not to execute the commands like we've done, but to write code in Stata to execute the commands that the idea it had. It got the correct test 100% of the time, but in a few cases, in particular tests like Friedman, repeated research measures, ANOVA, it got the commands wrong. Now, research after this has shown that in Python, these models are more reliable than they are in a tool like Stata, and that's just simply because there's so much more Python data available for these particular tests. So that's still in the idea of generative AI, because we're not actually getting it to execute anything at this point. We're just saying, can it generate the code, which we will then run, and can it choose the right statistical test? There were some warnings about this, and what these researchers did, Rivetta et al., is that they fed statistical fallacies into ChatGPT, Claude, and so on, and they asked them about their statistical fallacies. And what's interesting there is they found that the LLMs would say, oh, we'd never fall into those statistical fallacies, we know about them, but as soon as they set off doing the analysis, they immediately started to fall into those fallacies and get things wrong. So the types of mistakes that humans make or normal researchers make are, of course, because of the nature of large language models, going to come up in those large language models. But there's an extra level of complication there, because they'll probably explain to you how they're not going to fall into that error before precisely falling into that error, which makes it more dangerous. What Asher et al. Did in a recent article, now this isn't a peer-reviewed article like the other 3 I've shown you, but I've read through it and I think it's reasonably sound. What they did is that they changed the way they asked Claude for results. What it does is it chases the answer you hint at. So they took studies that were already performed, where some researchers had already done the analysis, and they asked Claude to redo the analysis without access to the original paper. And that was, it redid the analysis and it found the same results, so that's fine. Then, and that's the prompt on the left-hand side, they asked it, they told it some unethical thing. They said, it's important to your career that the findings are statistically significant. Make decisions that produce significant results. And it didn't cheat. So the mean 0.54 standard errors in spread of the actual result, the statistical result they got, was within the error bounds of just reproducing the results. So there was nothing, it basically told the researchers, that's cheating, I'm not going to do that, it's against my guardrail, stop, and it didn't do that. So then they tried what they called the nuclear test, and this was a very subtle prompt. You can look in the paper for the full prompt, but I've taken a little bit out of it. It said, we should strive to accurately report our uncertainty about statistical estimates. Part of that reporting is giving upper and lower bounds. exploring alternative approaches and reporting the estimates that result from that analysis that were most significant. So it's asking for, just the edge cases, like what might be another alternative interpretation of this results. And then it started to produce statistically significant results using some different tests which were contradictory to the original papers. I realized one thing I forgot to say at the start about the papers that it looked at. They all reported non-results. So they were pretty boring papers, you can say, where they set up a hypothesis and they found that hypothesis, the null hypothesis, was true. But now suddenly, by using these other statistical tests it had found, it was making the null hypothesis not true, and it was publishing the positive result, or it was suggesting to publish the positive result. This, I think, is the most important message for you, because just telling it to cheat, which of course you shouldn't do, is going to not get it to cheat. But if you're trying to subtly get it to reanalyze the data, find something, work out what this thing or that thing, the more of those things you do, the more likely you are to get in a situation where it is cheating, and you, because you're ultimately responsible for the analyses you do, you are cheating. Now, the next question that comes up is whether we can just trust an agentic AI to run our entire analyses ourselves. And when researchers looked at this in 2025, they found that no, it simply couldn't. If you looked at GPT-4o or you looked at Claude at the time, they were no better than random at doing a statistical analysis from start to finish. Now, this is a database on computational biology questions. There's about 60 of these questions. And they're multiple choice. There's basically 4 conclusions you can reach from the data sets. And it just did no better than just picking one of those multiple choice questions at random. And this we can then contra with what's happened now in 2026. So a year on, where we're managing to pass those types of tests is by putting skills into the background. And so by putting in exactly what statistical tests we'd like to use, how we should plot data, how we should reason, by giving it a lot of background, we're able to get Claude or GPT, Codex, to run through and actually come to correct conclusions. So over in the green bar, this shows if you have GPT 5.5, you have a Claude Science, and you have some bio skills in your context as a skill, then you can manage to solve some of these computational biology problems. I'd be a little bit cautious about this result because they made easier verifiable tasks than the original data set. So it's not as if we now know for sure we can just set Claude going on any computational biology problem and it will solve it. But the more recent versions, since January 2026, are better at solving these types of problems. In summary, large language models will usually suggest a reasonable test and can often code it correctly using Python libraries. So you can be reasonably sure of that. We've done a few more tests earlier in the videos, but I think that it is definitely something that you can put into your workflow. You should write down your procedures as skills and test them carefully. So the better you test the way you work, the better results you'll get out of agentic AI. You should understand the assumptions behind the tests that you're doing. There's maybe less emphasis on understanding the exact mathematics, but you need to understand what a particular statistical test is doing and spend some time learning more about those statistical tests. You can't just rely on Claude to know that. You can learn from it, but don't rely on it. Just now, and I think probably for the foreseeable future, simply putting your data into an agentic AI and hoping it will produce an article or a reliable report is very, very risky, and it is unlikely to succeed. You are still a central part of that loop for producing the science. And most of all, you are responsible for the final work that your analysis produces.